The world has changed a lot, but our education system or our learning system has not changed much. Do you agree with me? Come on, just by using a digital projector or a smart board is not going to bring the change in your learning. Myself, Sekhar, presenting you a brand new and innovative teaching methods which will let you fall in love with engineering, and it will also help you to crack any exam, GATE, ESE, Transpose, ZENCO, any state government, central government jobs, any job you can crack it very easily with the help of our 3D animations, live demonstrations, and interacting and interesting simulations, specially designed tools, which will not only clear your concepts, but also let you fall in love with the learning and explore the beauty of engineering. Check the link in the description to get a 365 days free trial course. Yes, absolutely free trial course for 365 days. Check the link in the description. Happy learning and enjoy learning. The world has changed a lot, but our education system or our learning system. Yeah. Hello everyone. Hello everyone. Welcome back. There was a slight delay of I think 5 minutes just because we had a technical issue here. I don't know whether the problem is resolved or not. My team has tried their best. Let's see. Anyways, we're back now. At present, I'm back. Just because you shared the video. Previous video was 100 shares. It's crossed 100 shares. So back. So for the next video, what you need to do? For the next video, like this video once this video reaches to 500 likes or maybe 100 shares, anything. Okay, then we'll go for the next video immediately in the next Sunday. Okay. Yes. Meanwhile, before we dive into the session, today's session is Bhimbra session number 7, right? PS Bhimbra MCQs. And today we are having very interesting questions. Rather, we have some interesting numericals. So I recommend all of you to get your calculators. Okay, all of you get your calculators. And before getting into the session, let me take some of your questions which you're having. Any questions regarding our videos, what we had done so far, be it the previous lecture or be it any one of our previous lectures. Some controversial questions we made, like why 50 Hz, why 11 kV, why transfer 1 kV, why AC in ton. Some very interesting questions, but some questions have become controversial because of some, half-knowledge people, I must say. So they were a little controversial, but okay, I'm ready to discuss about it. Okay, but not in chatting and all these things. You ask me in the question section, in the live chat, I'll be answering live. Okay, that makes more sense, isn't it? Okay. Hi everyone. Praveen is saying, according to Ohm's, voltage is proportional to current, but according to power equation, it is inversely proportional. Please clarify. What's that? According to power. Okay. Can somebody clarify Praveen's question? He's having this question is, let me put this question in a different way. Some people will say, yeah, absolutely, Ohm's law if you take, but if you apply that Ohm's law to a transformer generally, for a transformer, let us see, if voltage increases, current will increase, isn't it? So, but in case of a step-up transformer, this question, a lot of students have asked me this question. Once it is a step-up transformer, voltage is increased at the secondary side, isn't it? But what will happen to the current? Current will be reduced. So as per the Ohm's law, as Praveen is saying, if voltage and current are proportional according to Ohm's, it's not Praveen's statement, it's rather George Ohm's statement. Okay. So he says voltage is increasing, so current has to be proportionally increased. But there, current is decreasing. Okay. So why not? Ohm's law is not getting applied there. That's what your question, People put up this question to me a lot of times. So this question also, what Praveen is asking, is similar kind. Okay. So yeah, Dinesh has put up very interesting point here. I must say, because of maybe chatting, maybe typing issue, we must have answered shortly, but I understood what Dinesh is trying to say. He's absolutely right. Okay, if somebody can explain a little bit, yeah, you can do that. Yep, that's because power remains constant in a transformer. Yeah, that's true. Just because, but Is Ohm's law has lost its presence there? Means is Ohm's law gone? Ohm's law is violated? You are saying power is constant, that's fine. Just because power is constant, so voltage is increasing, so current is decreasing. Does it mean it is violating Ohm's law? Is that the point? That's what a lot of students have asked me this question. Yeah, you can try answering this. That's going to be an interesting session. Because kVA must be constant. Yeah, that's true, dear. That's true, Anurag. But the question here is what? Is it violating Ohm's law? That's the question. Is it violating whatever? Constant power, constant apparent power. But is it at a cost of violation of Ohm's law? Is it that? Yeah, I'm looking for some interesting guys should give me the answer. We're having some technical issues here. Yeah, Yeah, meanwhile, no, not at all. Ohm's law is not violated. Yes, that's true. Anurag, that's true. Ohm's law is not violated, but according to your statement, voltage is increasing, current is decreasing, means it appears like Ohm's law is violated, right? It appears like Ohm's law is violated just because voltage. Now tell me, how Ohm's law is still intact there. That make things interesting. Okay. Ohm's law is valid either only on secondary side or on primary side. Transformer never violate Ohm's law. So why, Kaushik, either on secondary or on primary? Why not both? Both are electrical circuit, right? Primary is also an electrical circuit. Secondary also an electrical circuit. So what do you mean by saying that? There is a sense, of course, absolutely for you. But I want some real interesting point which Dinesh has made. I want a little elaboration for that. Somebody please. This is not your question. I think all of you must be having the same question when I'm explaining this portion. This is what a lot of students have put up this question to me. Yeah, thumbs up the video. I told you for the next video what you need to do. Immediately we'll go for the next video the moment we got this video 500 likes or 100 shares. So once the session is over, before you leave the session, share it. Now you hit the thumbs up. Yeah, Shivram, that's true, dear. Here the question is it at a cost of violation of Ohm's law? How many of you are having this question? Tell me. How many of you want to know the answer, or how many of you already know the answer? Tell me. Put it in the comment. Put it in the chat box. Yeah, do it. It is valid for linear elements only. That's true. But we're talking about now present case. How you are saying still Ohm's law is intact? You said Ohm's law is not a violation. It's not getting violated. So how is it still intact? How many of you want to know? Put in the comment. Write it in the comment. Write it in the comment. Chat, I mean. Yeah. As transformer is inductive nature, Ohm's law is not applicable only. Inductive nature not applicable? No. It's AC, you can take it as it's a constant frequency, right? It's after all an impedance. So why you're saying in case of an induction, it's not going to happen? Of course, once it is set into saturation, that's all a different story. But for now, for the sake of simplicity, let's not keep the core into saturation. If Ohm's law is violated, then it opens circuit. I want to know what is the power factor correction. Okay, I'll not take up any new question. Power factor, all this thing I told you, right? That's we may have to discuss in a different session. Okay. All. I think how many of you know already? How many of you think you know the answer? Meanwhile, I'll set up the answer for you. क्या हो गया देखो नहीं हो रहा है ठीक है चेंज करो yeah okay so at constant temperature Ohm's law is valid for at constant temperature. No. Okay, let's come to the answer. Let's come to the answer. Now all of you focus on the answer. Don't focus on chatting now. I mean, don't focus on messaging me. Okay. I already gave you the chance to message me. You did already, so it's my turn. You listen to me. Okay. Number one, definitely it's not a violation of Ohm's law. Ohm's law is still intact. Okay, I'm not considering saturation, but still it is intact. Okay, Ohm's law is still intact. But the question is, how in case of a step-up transformer, how many of you watch a step-up movie? It's not I'm talking about step-up movie, step-up transformer. Primary is having, let us take 100 volts. And the secondary is having 1000 volts. So it's definitely, 1:10 transformer. Let us take primary current is, for the sake of simplicity, I'm taking as 1 ampere. Okay, so secondary current will be how much? Let's take it as 10 amperes. That makes more sense for us, so that we'll deal with easy figures, easy numbers, I mean. So secondary current is equal to how much? 1 ampere. Okay, so some of you rightly said, I think the context might be, you might be thinking would be this, you need to see individual, this is a different circuit, this is a different circuit altogether, and this is a different circuit altogether. There is no electrical connection between these two. There is no electrical connection between primary and secondary. Absolutely no electrical connection. It's a magnetically coupled. Okay, so don't see both these circuits as one circuit. You have to see both are two different circuits. Okay, these two are two different electrical circuits. Now tell me, if I cannot suppose some load over here, some load means how much I need to connect? Yeah, for allowing to the 1 ampere, it should be 1000 ohms. The moment I connect here 1000 ohms, definitely I is equal to V by R. Voltage is 1000, current is 1000. So 1 ampere is flowing. That's what ohms do, right? Voltage is equal to, don't say sir, voltage is increased. Who said voltage is increased? From here to here, there is a change in voltage. I told you this is a different circuit, this is a different circuit in terms of electrical circuits. So just look at this. That's what one of our user has given. You have to see primary and secondary both are two independent circuits. Okay, so 1000 volts, it is satisfying. Now you have to keep one very interesting point in your mind. That is, when you see a transformer, the primary current, if you want to find out the primary current, how do you find out that? You refer this resistance to the primary side. Okay, refer to the primary side, refer to the secondary side. I think you must be knowing all the aspects, right? So the moment it is referred to the primary side, that will offer 10 ohms resistance. Okay, onto the primary side, this will offer how much resistance? That's what impedance matching. Another very important application of a transformer is impedance matching. Like in case of analog electronics, it's a CC configuration, common collector configuration. So this 1000 ohm will become 10 ohms once it is referred to the primary side. That will make it as 10 ampere. So again, ohms law, check it. I is equal to V by R. It is still intact. Okay. Now, why V proportional to I, primary, secondary, you're clubbing those two, that's not correct. Okay, I hope you got a clarity, okay, on this much confusion part. Okay, people do get confused. A lot of students have come to me with this question. Hope this has cleared your doubt. Now, the second question, which a lot of students once again will have this doubt, which was the question was discussed in the previous video. So I'll be talking about that now. What's the question? The question is this. I think, let me zoom it a bit. Okay. So this question already in the previous session, I took up this question. Okay, and answer, everybody knows answer. Motor will attain dangerously high speed. Can you just type here? First of all, for the previous transformer thing, is it clear or not? Praveen is the one who has started this question, right? So are you clear, Praveen, first of all? Second, those who wanted to know the answer, are you all clear with the answer? With the previous question, I mean. Ohm's law is valid for electrical circuit but transformer, in overall a magnetic coupled circuit, but the primary and secondary circuit says it is invalid. Okay. Are you guys clear now? Are you there? Or slept? Or gone? Yeah. Yes, that's the spirit. We find that response. I explained this much. If we don't give that like and response, then from where will I get the energy? Now coming to this, a beautiful question. This question is what? Nice. This question is already become that. Now comes to the explanation part. Okay. The explanation for this, the actual doubt here will be, of course, equation wise you can say, if flux is reducing, speed will increase. So if flux becomes 0, speed will reach to infinity. Okay, this is what the equation says. But how physically you can feel that when there is no flux, there won't be any torque for the speed to pick up to that high value. There has to be some driving force. The twisting moment of force is driving the speed when rotating the motor. Okay, the twisting moment of force is called torque, right? So now, as flux is 0, I can see from the equation, torque will become 0. As torque is becoming 0, how it is accelerating to such high speeds? That's just completely annoying thing. Yeah, somebody I think gave the answers. Not really. If you're not really understood, you need to watch it again or watch it again. That's it. Yeah. In a balanced 3-phase star load with all impedance same. Oh, you're asking a question. Come on. Yeah, I'm asking a question now. You need to answer that. With field circuit open, the flux remains is only residual flux, which is very less, so speed will rise. See, that's what the equation says. But physically, how you're feeling? As flux is less, torque also will become less, isn't it? When the torque is becoming less, then how the speed is picking up? Don't say in terms of equation. Okay. If flux reduces, EB reduces, and IA increases. Okay, I think Upendra has said very interesting point. All of you just focus on that point, what Upendra said. Okay, so I think you got the question right. Now, what Upendra is saying is, if flux is reducing, EB reduces, that's fine. Okay, flux is reduces, EB is reducing, IA is increasing, back EMF is reduced, armature current has increased, fine. And torque is increasing. That's what you're saying. Your statement is torque increasing. My statement is, this point is very important, Upendra. You mentioned a very good point, but slight extension is needed for that. Slight extension, that's it. I want all of you to tell me that extension part. Okay. So I'll ask a question, then you answer to the question, automatically the extension will be done. Okay. If flux is reducing, now to compensate that flux, accordingly, armature current is increasing, isn't it? The product of these two is a torque, which is constant. If torque is constant, then why it is accelerating? Load is having 5 Newton meter, let's take that. How much is the load? 5 Newton meter. Now, because of the reduction of flux, torque has reduced, that's what I'm saying. But Upendra said, a reduction flux, I think I should write that. Okay. Isko change kar do. What was I saying? Yes. Point is very important. Load torque is how much? Load torque is 5 Newton meter. Okay. Let me consider here for us to feel it. Flux has become half, 50%. Okay, flux has become 50%. I'm just generally saying what Upendra meant to say. Okay, flux has reduced to half. This is what my question. Then what he's saying is, sir, current EB as flux has reduced. EB is reduced to how much? half. As EB is reduced, we know the formula IA is equal to V minus EB by RA. So IA increases. Okay. So as flux is reducing, current is increasing, torque is proportional to phi into IA. So torque, you're saying increasing, you're saying it is increasing. Generally, a common person will raise a question that, sir, it is not increasing, it is maintaining. Okay. Then, if that is a question, what will be your answer? Okay, what will be your answer? Load torque is less than electromagnetic torque. Load torque is always constant. I am saying at a constant load torque, I am doing this change. At a constant load torque, I am reducing the flux. That's a statement I have given. Now, I think things are there right in front of me, right in front of you. Okay. You just have to mix and match these things, then you'll get the answer. I think Upendra can make it out. Actually, flux is not zero. Let's not talk about zero flux. Okay, zero flux is, last case. First, you tell me about this 50% change in the flux, reduction in the flux. I mean, half of flux is getting half. The speed has to increase, right? So let's talk about that case. Then we will go further. Pooja, you made a point. 50% of your point is true, but not the remaining 50%. But that's a very good attempt. That's a really very good attempt. Yeah, I want some of your thoughts. Unless you share your thoughts, how it's going to be interactive? Come on. Yeah, share your thoughts. Like, share your thoughts also. What are you doing? Are you doing something? Or just listening to me? Alright, this is crazy. I'll give it. No other comments, I think, from anybody? You want me to complete that, or somebody want to say something? At least this, you tell me. Or you want me to wait? I'll wait then. Shine. Thank you. Oops. Yeah. Shunt field open means residual flux is still maintained and decrement. Wow. Upendra, I know you could do that. You're amazing. The statement is started right from the beginning itself. That's true. Here also, yes, he made it. Okay. So what's the point he's trying to make here? Just look at the point he wanted to make. Okay. What's the point? Point is, let me highlight his point. In that important point is, oops. Oh, yeah. That's an important point. This is a very important point, which will give the answer to all of us. Okay, that's an answer. That's an complete answer for the question. Okay, Upendra has even started saying something before, and he finished it. He finished saying it. Okay, now let me complete. At least we got something from our student. That's great. Now I'll finish it up. Okay. Flux will decrease. Sir, you from Vadodara? No, I'm not from Vadodara. Okay, now coming to the answer. Careful here. The moment flux has reduced to half, definitely EB will reduce to half. Why? Because the moment flux has reduced, momentarily, speed is not going to reduce because of its transient. That's what somebody was saying. Okay, due to the transient nature, because it's moment of inertia, to be more precise, speed will not change suddenly. Speed will be almost same. As speed is almost same, EB, we know EB is proportional to phi, sorry, not equal to, proportional to phi and n, speed, phi into n. Now, n is almost constant, I can say. For the momentary case, I'm saying, momentarily I'm saying, okay, for that particular moment, flux speed is almost constant. So EB is proportional to phi. Phi has reduced, EB has reduced to half. You take some numbers, okay, you take some numbers. Let me consider V is equal to, let's take it as 200, okay. So earlier case, in the right at the beginning, EB1, let me consider EB1 as maybe 190 volts, okay, or maybe 180 volts. It makes things easy for us to calculate, okay. 180 volts. The moment flux has reduced, EB has reduced to how much? 90 volts. Suddenly, momentarily it has reduced to 90 volts. This reduction of 90 volts from 180 volts will, you put that here, means you consider RA is equal to 1 ohm. So 200 minus 90 is, 200 minus 90 is how much? 110 ampere. Current will rise to 110. Can you believe this? 110 ampere, that's huge current. Okay. Earlier, how much was the current? When EB was 180, how much was the current? Just bloody 20 amperes. I put that 200 minus 180 by resistance is 20 amperes. Just because flux has become half, the current has become 110 ampere. It has not become double. Momentarily, the current shoot up to 110 ampere. That will shoot this torque developed within the machine to how much? To very high value. So torque developed is more compared to the load torque, which is just 5 Newton meter. Then machine will accelerate. Accelerating. Machine is picking up speed. Now at steady state, why it is accelerating? It's just because electromagnetic torque is much more than load torque, so it is acceleration. Okay. And as it is accelerating, speed is increasing, so EB will slowly pick up. Okay, so armature current is slowly coming down. Speed is picking up, EB is picking up, armature current is slowly coming down. So at equilibrium point, speed will settle. That equilibrium point is much above the present speed. Now the same thing, if this comes down to a very low value, then this EB will come down to very low value. IA will go up to very high value. The torque developed will be very high. That will very quickly accelerate. Okay. This is what the concept. Hope all of you understood. The point. Keep it in the chat section whether you understood or not. Upendra has made it among all of you. Upendra has made this. I think you know the offers which are going on the PiSquare, because we completed 74 successful freedom years, right? We entered into 75th Independence Day. So we have offers at our website. You just go and check our website so that you'll get good deals. Yes. Share it. The previous question and this question, I think we can end the session. These two things are very key aspects. The earlier one, what I discussed, flux, transformer, transformer voltage increasing, but its current is reducing, how it is happening, that's what I discussed. Now, another most mind-boggling thing, that is, when flux is reducing, how speed is increasing. Okay. So, let's discuss about the remaining questions, right, in the next session, because if we talk about other questions also in this, we lose the importance of these two questions. Rhythm. Are you from AP? Yes. I am from Andhra Pradesh. I am from Kakinada. I know Telugu. Naku Telugu vachu. Naku Hindi vachu. Okay. I think you understood, right? Yeah, fine. I was saying I know Telugu because I'm a Telugu guy. So how come I don't know Telugu? Mu kohi parive. ଓଡ଼ିଆ କହିପାରିବେ ମୁଁ ବୁଝିପାରିବେ. Yes, guys, that's it. So, yeah, what else? I think we'll end the session here. So, if you have any questions, I'll just take up that. What about Tamil, sir? No, I don't know Tamil. I can understand Bengali. I can understand and I can speak a bit of Odia, yes. Hindi, English, Telugu. I've been to the southern states of India. So, except, of course, my hometown. Okay, guys, thank you for joining me. Okay, and this beautiful sessions. And Upendra, I think, yeah, let's give it up to Upendra. Upendra, are you there? Are you there? Malana. Hi. If Upendra is there, then I'll give coupon to Upendra. Indian, yes, I'm an Indian. What about you? Can you explain the operation of alternator connected to grid system? Okay, Upendra, it's already our courses. Upendra, you're about to get a coupon. Alternator connected to grid system is there in the synchronous machines, I think, alternator section. So just because you answered the session very well, I would like to give a special and exclusive coupon to Upendra. Okay, just contact us on our WhatsApp. Okay, contact on WhatsApp. Our WhatsApp team will communicate. If not today, maybe tomorrow morning they will communicate. They will give you a special coupon so that you'll not only know how the alternator is connected to grid and all these things, you'll know the complete machines just with the beautiful animations which is developed by us. Enjoy it. Okay, you'll get a lot of things along with obviously your question. Apprenticeship? No. Electrician knowledge? It's about that. It's for AEs and all. Apprenticeship, electrician knowledge? No. You can go for basic electrical engineering if you want that. Following standards will acquire concept. By following standards will acquire concept. What do you mean, Kartikeya? Standards? You want to see standard books? What's that? Hello, Saurav. Yes, thumbs up. Okay, shall we wind the session? Sir, tell about balanced three-phase star connection question which I asked at the start. See, I told you, right? I'll take on the questions which we discussed so far in the previous lectures. Okay, I not even see the question. I'm in books. See, tell me how I got the concept. I acquired the concepts. How anybody in the world would acquire the concepts? From the God, you think God will directly dump the concept into your mind? Obviously not. The only best source is what? Standard text. That's a primary source. Okay, not the only source, I should say. The primary source is the standard textbook. Okay. Now, as a teacher, we are referring to those standard textbooks, and we understood that. And actually, we at our team, what we're developing is whatever we understood from the standard textbook, because in a textbook they cannot visualize the things up, right? So we are putting our imagination and we're giving the visualization to all of you. Okay, you have seen the intro part, right? How was that? Wasn't good? That would be amazing because no one else is doing that. PiSquare is doing that. The only PiSquare is doing that. That's what the tagline, right? It's going, right? Yeah. What's the tagline going? Yeah, what's the tagline going? Tell me. We help in bridging the gap. There is a huge gap. The pi also symbol, you see that? There is one, there is another. That's bridging the gap with multiplied effort. What's the multiplied effort? With animations, which you would never get anywhere. It's 99899. Let me type that number. You can go to website or check it on the comment. It's done already. You check it out. Okay, guys. Thank you for joining me. And for the next video, we'll have to do the simple task. The task is like this video and share this video with your friends. If you want more videos. Okay. If you don't want more videos, then don't do it. Okay. So that I don't have to make another video. I'm not compelled to make another video, I mean. So 500 likes if you get for this video or 100 shares, you'll get a new video. Have a good day. Bye bye. ठीक है खत्म कर दो